office hours. We have another special guest today, Dustin Spinner. I call him Spinner. It's Spinhirne. And he's going to be taking us through a lovely networking discussion, touching on some of the new features that are becoming available. I think they're available now in semi-release fashion, and soon is going to be available to everybody. So we thought we'd kind of go over some of that stuff and just kind of give everybody a heads up of all the features that are coming. So with that, Dustin, I'll throw it over to you and maybe give everybody a brief introduction of who you are and take us down the network.
Sure thing. So my name is Dustin Spinhirne. I work as part of Matt's team on the VMware Cloud on AWS product line. And so today, what we're going to do is talk a little bit about NSXT, particularly what the differences are architecturally between the V implementation. And this is as it pertains to VMware Cloud on AWS. And so just a heads up, asked to do this presentation earlier, so these slides, I was kind of putting these together today. It's sort of a working process, so these are really rough, so you'll have to forgive some of the rough animations and scribbles I have in there. I think it's enough to get the point across, so we'll just go with it. All right, so the topics we're going to cover today, we'll discuss the networking model. This is going to be similar to a discussion I have on the NSXV side. So we'll show how the SDDC is laid out and as it relates to the the Amazon environment and the on-prem environment. Talk about network security, since that's one of the new features in NSXT and how it's a bit different than what we've currently had with NSXV. And then we'll talk now about Direct Connect. It's a topic I don't typically cover with the V product line unless I'm specifically asked. And the reason we're covering it now is because under NSXT, it's actually functional in a way that you would expect Direct Connect to actually function. So we'll talk about that specifically public VIF and private VIF and how it relates to NSXT. And then lastly, we'll do a quick run through of the networking tab in VMC and what it looks like with some of the changes in NSXT. So if anybody has seen one of my onboarding videos, this diagram should be somewhat familiar. Now, granted, the animations are not in on this version, so you'll have to try to not get distracted with all the busyness going on. I tend to animate this to try to keep focus most of the time. Animations aren't there right now. So specifically what we're going to talk about here, I'm going to run through sort of what I talk about on the normal onboarding calls, but I'm going to alter it slightly for how it relates to NSXT. So the first thing we're going to look at is this SDDC. Hopefully, Matt, you can see my mouse moving here.
Yeah, we can see your mouse moving. And just so everybody knows, the SDDC setup and stuff we covered week one. So if you kind of want to go back, you can watch kind of the creation of some of these things and I'm sure Dustin will touch about the slight difference in how the edges are configured from when we talked about this briefly earlier.
Yeah. So if you've seen the earlier diagrams, one thing you'll remember is that in current implementation with NSXV, so we have the CGW and the MGW. That concept has ported over to NSXT. Say, these both serve the same function. However, they are now their position in the overall picture has changed slightly. So let me start just for people that are not familiar. I'll just cover what these are. So starting with the MGW. MGW is the management network. So infrastructure components for the SDDC reside within this network. So we've got vCenter, NSX, ESX, all of those components. This is where they're getting their networking. All right. And now the management network is bordered by an MGW or management gateway. This gateway is the north-south router for this environment. It's also providing security. Now I asterisk that a little bit, saying it's providing security because it's different in T. Now in NSXV, this is an NSX edge router. In NSXT, this is a distributed router. All right, so that's the management network. Compute network is going to be very similar. So compute network, again, it's bordered by this compute gateway, which is the CGW. Now the difference here is that on the compute network, you have flexibility to add new subnets, within this network. And again, you have more control over the security. On this side, we've sort of locked down the security, what you can, what ports you can open up. to make sure that you're only getting to HTTPS of vCenter, for example. So that's the main difference between these networks. So they're two functionally separate networks, serve two functionally different purposes: management and then your workloads. Now, what's different between this and what we have currently is that in NSXV, the CGW and MGW are exposed directly on the internet. So, in other words, they have public IP addresses configured on their outside interfaces. They are the outermost devices for their respective domains. Now, the big change architecturally with NSXT is that NSXT has different concepts of edges. So it has this notion of tiered edges. So you've got this concept of a tier 0 uh, edge router, which is an appliance, much like the NSXV edges are. And then you've got tier 1 routers, which are distributed routers. And so in this design, the edge, we have an outermost edge, which is a tier 0 router. This tier 0 router is the device that is the north, south, central uh, ingress egress point for the SDDC. So it's a single point. It is the only thing with a public IP address. It is the only thing exposed directly to the public internet. The CGW and MGW, on the other hand, these are tier 1 routers. So in other words, they are distributed routers. So that is the main architectural difference, is that previously we had these being outermost. If you wanted to establish VPN, you had to do a separate set of tunnels between them. And then if you wanted to communicate between these two environments, you actually even had to set up an IPsec tunnel between the CGW and MGW. So now that we've moved this into a more tiered architecture, we don't need a lot of that stuff. So since I'm on the topic of VPN, I'll discuss that now. So you'll notice here, one of the big changes is we have the on-prem environment drawn up here. You'll note that we only have a single IPsec VPN tunnel going to this edge device here. Now, one of the new features of NSXT as well, previously we've only had policy-based VPN, which is somewhat less flexible than what people want. Typically people are used to, particularly when they're dealing with Amazon, they're used to dealing with route-based VPNs. Route-based VPNs provide basically the ability to run a routing protocol over the VPN, provide you a means of setting up dual tunnels to redundant devices and having routing protocols fail over, et cetera, et cetera. You don't have that with policy-based VPN, but with route-based VPN, which we now support in NSXT, we have some of that functionality. So the ability to have single tunnel or single tunnel to a single edge device, ability to have redundant tunnels to redundant devices for network failover, ability to run routing protocols over the IPsec VPN. So those are the big enhancements with IPsec. Now, furthering that discussion on the inside of the network, previously, like I mentioned, if you wanted the compute and management networks to communicate, you had to actually set up a VPN between them. Here we don't need that, because this is it's tiered behind the single edge. We can just route straight between these. Now, one of the key things to keep in mind, and I'll discuss in the security model here in a bit, is that even though we have a direct routing path, this edge is still providing the security. So it's providing security both north, south, and then also between the tier 1 routers. So we'll have to keep that in mind when we're setting things up. So you have a security enforcement between these two networks. Now, going into the customer VPC side, this is going to be very similar to what we have today. Now, today, again, the way we're cross-linking into a VPC, and that's what this is indicating here. Whenever you set up an SDDC, one of the things that we will do is have you choose a VPC within your Amazon account. You will choose a subnet within that VPC, and then we will configure a cross-link between the SDDC and that subnet. And so on the back end, the way we're implementing that is by creating a bunch of these ENIs within that subnet, and these ENIs tie back to the ESX hosts. Now, ultimately, what this was doing was this was patching in to the CGW on NSXV implementations. So today, this ENI pipes directly into the CGW effectively. And so what that means in today's version of NSXV is that only the compute network had access to these subnets. Now, as you can see from this diagram, this architecture has changed somewhat. Again, we're utilizing the tier 0 edge router for this. And so in this design with NSXT, this E&I is effectively piped into the edge. And so what that gives us is the ability to not only connect the compute workloads with these subnets, but also the management workloads, the vCenter server and NSX and things that are within the management domain can actually route through and hit the customer VPC. So that's one of the big changes. So skipping ahead now, that covers the high-level architectural design of NSXT and the changes that we've made from NSXV. So skipping ahead, we'll talk about the security model a bit. And so focusing in on the SDDC, we see our tier 0, tier 1 router layout. Now, there's 2 points of enforcement for security that we need to keep in mind. So the first point of enforcement is on the edge itself. So the edge is very similar. If you're working with a product today, you'll see a very familiar feel with what the CGW and MGW did, where you define edge firewall rules. The edges by default are default deny, and that we've carried that over in this design. So in the NSXT world, the outermost tier 0 edge has a edge firewall feature enabled. Default deny by is the policy enabled on that, and so you have to explicitly permit traffic through this. Now, a second layer of firewalling is the distributed firewall. Now, the distributed firewall is this happens within the logical overlay. So, in other words, it's not really being enforced on the CGW. So typically, when people think of network security, they're imagining a centralized device performing that. Now, that is the case on the edge firewall. It is effectively a centralized device. It is the thing that's performing the edge firewalling. When you get into distributed firewall, that is taking place at a lower layer effectively. So it's not being done because these are distributed routers. There's not actual device sitting anywhere that's doing this firewalling. It's a distributed function that's distributed out into the actual overlay itself. So distributed firewall is in the T world is restricted to be able to. You're basically restricted to only being able to configure rules that apply to the compute network. So in other words, I can define now, as previously it was, we can only define firewall rules north-south. With distributed firewall, I have the ability to define firewall rules to restrict communications east-west within the compute network. So in other words, I now have the ability to prevent VMs over here from talking to VMs over here, or even I can restrict VMs within the same subnet from talking to each other if I want to. Now, the difference with the firewall policy on the distributed firewall is on the edge firewall, we have a default deny policy. On the distributed firewall, we have a default permit. So you have to explicitly deny traffic in this model. So taking this a step further, we're going to focus down a little bit on the distributed firewall.
And just for everybody watching too, sorry, Dustin, to just jump in for a second, let you take a breath for a couple minutes. Dustin's actually going to take us through some of this interface as well, and how it looks and how it you're able to create those rules, because it is not NSXT, if you're familiar with that, or V. We have kind of a custom portal for it. Is that kind of correct?
Well, what they've done is in the VMC console, they're actually setting up an iframe and patching that right through the NSX manager for NSXT. So you're actually, the interface you're seeing is actually NSXT's native interface. It looks very. They may have done some some slight modifications to it. I'm not entirely sure on that, but it's mostly NSXT as far as I'm aware.
Okay, sorry, continue on.
All right, so compute network. So one of the things that I want to focus on here is the distributed firewall, and just this is something that tends to be somewhat difficult for people to grasp at first, and so I like to always specifically call it out. So, like I was mentioning earlier, distributed firewall. When you think of firewalling, you're usually imagining firewall enforcement being done on some centralized device. That's typically how we've done it for the past several decades, right? So traditional firewalling, if you wanted to set up a three-tiered app, and in my example here, I've got web app and database tiers, and then I've got some outer tier, which is my users will just I just label it VM1. Now in traditional networking, the way security worked is you only had the ability to filter on a centralized device, and so that led us to certain design decisions. So if we wanted to secure between the different tiers of a three-tiered application, what we had to do traditionally was we had to create three separate subnets. We had to put our devices on their respective subnets, and then we had to apply security policy on this centralized device up here. And that's how we secure between those different tiers. Now, with distributed firewall, we no longer have this reliance on a centralized device in order to force security. So security is enforced down beneath everything. So you can almost imagine distributed firewall as being a little transparent inline firewall that sits on this interface between every VM and its connected network. So distributed firewall is pushed down to that level. It's applied, basically at every interface of every VM. And so what that gives us is additional flexibility in how we design our networks. So traditionally, when you think of a three-tiered application, people immediately start creating separate subnets and start lumping their VMs into their respective subnets. Now with distributed firewall, what we have is because the security is defined below that level, it's not defined at a centralized level. We have the ability to have complete flexibility on how we lay out our subnets. And so I would propose that if I were to design a security system saying that my web can only talk to app can only talk to DB, I could do that with distributed firewall. And from the perspective of a network design, the security would look identical if I had four separate subnets or if I had one giant subnet and everything was plugged into it. From a security perspective, makes no difference. Security is going to be applied consistently regardless of what our subnets look like. And so that's one of the key things that we want to keep in mind when we're using distributed firewall and how it affects or potentially how we design our SDDC networks. Now, one of the other things that we like to talk about on demand is direct connect and how it works today. So direct connect with the product today, it works, but not quite the way you expect it to work. So direct connect in Amazon is basically it's a private line between your environment and the Amazon environment. Now with direct connect, we have two different flavors of VIFs that we can configure on our direct connect. So we have a public VIF and we have a private VIF. Now, public VIF is intended to allow you to short circuit your connections into the Amazon public address space instead of normally going through the internet. Direct connect public VIF allows you to cut through a direct connect for public IP access. Private VIF, on the other hand, gives you direct access into VPCs within your Amazon environment. So you have direct access to private IP address space. And so that's the big difference between the two. So let's talk about public VIF first. So in this diagram, what we see here is we have on the left, we have the Amazon environment, we have an SDDC. I've got an edge sitting there. I've got HCX appliance installed. These are connected to the public network in the Amazon. I'm calling it the AWS intranet, and you can see I have a little /17 that's actual AWS address space. And so your connectivity, if you've got your on-prem environment, let's say you've got a VPN set up and you've got HCX deployed, your path is going to be like this through the internet by default, because you can see from your routing setup, you've got a default route that's just pointing to this internet router. So this is your normal path. Now, let's say that you're doing a ton of traffic, or you want to improve the latency between your environment and Amazon. And so how do you do that? Well, an option is setting up direct connect. Well, if you're talking about IPsec VPN, well, that's terminated on the public IP of an edge. If you're talking about HCX again terminates on public IPs on the cloud side. And so by its nature, it's going out the public internet on your on-prem environment. All right. So if you want to bypass the public internet, what you can do is you can set up a direct connect. Now, Direct Connect is going to give you a direct path into Amazon. Now, if you want to start pulling traffic off of the public internet and onto the Amazon environment, well, how do you do that? Well, you set up a public VIF on this Direct Connect, and as soon as you do that, Amazon is going to start advertising their public address space to you via this Direct Connect. And now, once they've done that, your path to Amazon is no longer on the internet. It is now through the public VIF on this Direct Connect. And so, in that regard, public VIF on Direct Connect is simply a public peering, right? They are advertising their more specific prefixes to you over this private line. And by the nature of routing, you are going to tend to take that path. And so that is public VIF on Direct Connect. And the types of things that you have to keep in mind that ride over public VIF or anything that terminates on public IP addresses in the Amazon environment. So anything that resides on this public IP address space. So in this case, Edge router, which terminates VPN, HCX, which has its own IPsec VPN tunnels for L2 extension, etc. These are all services that ride on the AWS public intranet, and so that is the stuff that's going to ride over the public VIF on Direct Connect. Now, private VIF, on the other hand, like I said, private VIF is a means for you to connect directly into one of your VPCs and access the private address space of that VPC. Now, in the product today, we suffered a fairly large limitation, and it was just a result of some of the policies Amazon has on Direct Connect private VIF. So the big thing with Amazon Direct Connect private VIFs is that they don't allow something called transitive routing. So transitive routing, and unfortunately I didn't have time to draw this out. Transitive routing would be if my path into my VPC was via this Direct Connect. Imagine for a second that I had this other VPC sitting up here, and I had a connection, through to another device, and I started trying to route space address ranges into this other VPC. If your path were for the on-prem into this VPC and then transiting through to this other VPC, that would have violated the transitive routing restriction of Amazon, and they would drop that traffic. Now, the reason I bring that up is that today we are impacted by that restriction in NSXV. So the way the SDDCs are actually configured on the backside is that we have this VPC that is within our Amazon account, and every time we spin up a new SDDC, we essentially create this dedicated VPC. We create the SDDC within that, and the SDDC lives within that VPC. Now, the things that actually sit within this VPC are the ESX hosts, because they're physical hardware. They get their networking at the infrastructure level from this VPC. And so what that meant previously or today in NSXV is that the only things were accessible through private VIF and Direct Connect were the ESX hosts themselves, and then only certain interfaces. So we exposed the vMotion interface and maybe VMK0. And so you could get to the ESX hosts themselves. Now, you couldn't get to anything else in the overlay. So inside inside of NSX, for example, inside of anything behind the CGW and MGW. And the reason for that is because if we try to advertise that private space into the VPC, Amazon would see that as us making this VPC a transitive VPC, and they would just drop the traffic.
And just a point of clarification in there, and you did call it out. This is dedicated. So some of the feedback or FUD I get out there sometimes is people saying, "Oh, this is all just shared on the back end for VMware." No, this is completely and entirely per customer, right?
Yeah. Yeah, and you'll note that I've named this the SDDC VPC, and it has a very specific range, and this is the range that you've given us for the management network of this individual specific SDDC. So yeah, to Matt's point, this is everything you see here is dedicated to this SDDC. So nothing shared. So anyway, back to the current restriction today with the NSXV world was that we hit that transitive routing limitation. The net effect is that you couldn't get to any of this stuff inside of your SDDC directly over private VIF. All right, so what did that mean? That meant you could set up private VIF and you could get to the ESX host, but if you wanted to get into anything else, you had to have VPN, IPsec VPN into the CGW and MGW. So effectively, in order to use your direct connect with the SDDC today and NSXV, you had to have public VIF as well. So not only did you have to have private VIF, you also had to have public VIF. Now with NSXT, this is one of the major enhancements that we've brought. So Amazon has made some adjustments on their end, and we've changed the underlying architecture ourselves a bit. And so basically the net effect is that we are no longer impacted by this transitive routing limitation. And so what that means is that if you set up direct connect private VIF, as soon as you set that up, we're going to start seeing a default route from the VGW, and then we're going to start advertising prefixes for the private IP address space for the SDDC. So you'll see the management range, and then you'll see the individual ranges for the networks you create on the compute network. So we'll start advertising those via BGP through this private VIF on Direct Connect. And as soon as we do that, your forwarding path becomes exactly as you would expect. You go through the private VIF Direct Connect into this edge router, and then you're in. Right, so that's your forwarding path. These all become reachable. Now, network security still applies, as if this was, normal internet traffic, because it's going through the edge, but you have a direct forwarding path into the CGW, right? Similarly, you have a forwarding path into the MGW. Now, one of the key things to keep in mind is that we have a slight difference on the way the forwarding path works within the MGW, depending on what you're trying to access. So here you can see in this example, vCenter and NSX, these are virtual machines. They live completely within the overlay, the network overlay, right? So your forwarding path is always going to be through this edge, through this MGW. Now, when we're dealing with just IPsec VPN, as per the previous example, your forwarding path is again always through the edge, always through the MGW. And so if you're using IPsec VPN, you're coming in. If you want to hit vCenter, you're going to come this path. If you want to hit ESX, you're going to come back through the MGW and hit ESX. Now, one of the differences with the direct connect is just the way this works. We have, because remember the ESX hosts themselves, these are sitting really they're partially they're sitting in the overlay, partially they're sitting in the underlying VPC. And so the impact of that is that your forwarding path for the ESX host, when you have private VIF on Direct Connect, actually goes direct through the VGW, and you can hit the vMotion and VMK interfaces directly through the view.
Yeah, so maybe it's good to highlight what kind of traffic that would be. So that would be vMotion.
Specifically vMotion, specifically VMK0, which is the management interface. Now, the reason I bring that up and why that's an important consideration is from a security aspect. If you're not aware of this, you may be trying to lock things down on this side and realize that it's not having any effect. Now, what we've done is we have taken and locked this down on our side so that only vMotion, only management is exposed. So it is secured. Even though this is private VIF, we are trying to secure it as much as we can. And so it's just an important differentiator to be aware of when you're dealing with private VIF. So is that clear, Matt? Any
Yeah.
questions?
So I mean, what about So the question might come up like, okay, what about if I'm using HCX or well, in this case that's not supported currently.
Yeah, HCX, all these services. So so I guess that is a good point on NSXT. So here we are talking about all this wonderful stuff with NSXT, and this is an important point to call out. I'm sitting here talking about this stuff. You're seeing features, wow, distributed firewall, direct connect, et cetera, et cetera. I'm going to start using NSXT today. Well, the thing to keep in mind today is that NSXT is in preview release mode effectively. So that means it's there and you can do the stuff that I've talked about here today. Now, what it also means is that everything else has not quite caught up. So HCX, site recovery, these things have not quite caught up with the NSXT release yet. And so if you need those things, those different services, you need to stick with NSXV today. At some point we will, they will catch up. We will make this the default option, and everyone can spit up new NSXT based SDDCs and get everything they expect. And then at some point we will just upgrade all the NSXV SDDCs as well. But today, if you need those services, NSXT is not for you. And then to the
it's coming very, very soon. Just to add that from what I've seen on that.
Yeah. It's
but
it's
a live vMotion is supported over this topology, right? with the direct connect?
As you have a forwarding path. I mean, you have a forwarding path today with NSXV, right? So you know, as long as you have HLM set up and you have a direct connect private VIF, you can make that work today over NSXV, and that story, doesn't change with NSXV. As far as I know, HLM is supported with the NSXT layout. Although I'd have to double check on that, but
Yeah, I'm pretty sure that that's correct. And in this case, you could actually use, I guess, the vMotion feature set entirely over private VIF as opposed to having a public VIF involved.
yeah, that would be one of the that would be the one of the big differences today is that even if you're trying if you're trying to do that with NSXV today, you'd still have to have the IPsec VPN because that's your path into vCenter. With with NSXT, yeah, that IPsec VPN requirement would no longer be there. So it's one less thing to have to worry about if that's your goal. Now, keep in mind, you asked about HCX and things like that previously. HCX, these things they go over public address space today, and so unless that story changes, the private VIF design will have no impact on that. We would continue to use the either the internet or the public VIF for anything that binds to public address space. Now, on the roadmap for HCX, it's possible that they intend to make enhancements to make this work over private VIF. I can't comment on that, but um, yeah, that would if they made such an enhancement, then yeah, it would work over this. All right. The next thing I wanted to go over was the console tour, and so I'm gonna stop sharing my screen momentarily. Give me one moment to get
Yeah, just
everything.
give us a second. We're getting into the fun stuff here, so or you can actually see some stuff ahead of what most people will be able to see. Benefit to coming into the Twitch hour. And again, anybody can post any of their questions in chat. And like we mentioned, the NSXT stuff is it's been in development for quite some time, but it's just in preview mode, and we've had quite a few customers running it and running it quite successfully. And it continues to gain more and more traction with our customer base. So, and as Dustin also mentioned, it's soon going to be the default.
Okay, so assuming you see my browser window here,
Yeah, we do.
this is the VMC console. You can see I have a few different STDCs created. Specifically, though, we were interested in this one here. And so mostly this console is going to look the same as what it does in NSXV based STDCs, but the big difference is going to be on this network and security tab. And so if we drill down into this, we're going to see that the view here has changed fairly significantly.
Yeah, if you don't mind, actually, Dustin, do you think you can open up like another tab and just kind of give the show the difference between the two? I think we have an old one sitting around, right? I think we have a V1. Might be Aiden's.
Let's think. Maybe I can come back to it so
Yeah.
it's not.
That's fine. Just for comparison's sake. But yes, it does look
Yeah.
significantly different than the other networking page.
Yeah, and again, keep in mind this is still somewhat early release, so any of this stuff is also subject to change, which we're
Yeah.
receiving feedback from.
I believe the line is don't lawyer me, bro, on this. So.
All right. So anyway, let's start up on the VPN side, and so the first thing you'll notice is you have more options on the VPN. So layer 2 was there before, but what's new is this route-based VPN. Give it a second here. All right. My UI seems to be freezing up on this one, so maybe we won't show route based. I'll talk about it. Had this come up, what this is gonna look like is very similar. If you're used to dealing with Amazon VPN, so VGWs, it's gonna be somewhat similar to that. So you're gonna have this notion of a VTI interface. It's just a virtual transport interface, I believe, or virtual tunnel interface, I think is what it stands for. And so essentially what that is doing is you're going to be asked to set up a point-to-point, typically a /30 address space link between the edge here, and that's not diagram, but there is an outer tier 0 edge. You'll be asked to set up a VTI between that edge and then your on-prem or whatever your destination is for your VPN on your side. Now, as part of that setup, what that's going to do is you're going to set up a tunnel interface on both ends of the connection. You're going to provide an address space for that tunnel. And so typically what you'll see done, specifically on Amazon side, is they'll use the 169-XX direct, private address space. And that range, that address range is basically a IPv4 link local address range. And so it's reserved specifically for point-to-point links. And so you'll see them typically use that. So what you'll end up doing is setting up a /30 point-to-point link essentially between this edge and your peer. And once you've got that up and running, it's IPsec encrypted, essentially point-to-point tunnel. And so once you have that up and running, the next step is setting up BGP as your routing protocol. And so you'll go through, and very much like on the Amazon side, you'll set up BGP autonomous systems on either end of the connection, and then once that's up, you'll start advertising address space. And so what we will do by default is advertise all the address ranges that you're using within the SDDC. We'll advertise those out via BGP, and then on your side of the connection, you have complete control over over what you advertise. So you can choose to advertise the default route in. You can advertise just the private address space of your on-prem environment, or your transit VPC network, or whatever the case may be. And so that's the big enhancement with route based. And and to that point, we have the ability to set up multiple tunnels. So we can set up a primary and a failover tunnel. You'll typically see that in transit VPC designs where you have two redundant devices, and so we would support that, where we could have redundant tunnels, BGP running over both of them, and then in the event that one of them fails, it would automatically fail over to the other one. So that is one of the big enhancements on the VPN side. Now, getting into the security side, we see here we now have two different types of security. So we have edge firewall, all right, and then we've got distributed firewall, which I'll go into here in a bit. Now, the edge firewall, the way we've got the UI segmented out is that we have this split into a management portion and a compute portion, right? And the security is based entirely off of groups, so it's group based. So if I'm on the management network, or the management, effectively the management network edge gateway policy set right here. And so what this means, you can see from some of the rules is I've got rules that I've named, and then I've got certain sources and destinations defined. So if I were to add a new rule, you would see that if I set the source here, I think when I opened up that other tab, I messed this up a bit. Let me.
So yeah, maybe you can open that up. I actually have on my screen. I'm going to bring it over here so everybody can see it on the stream. The route-based VPN tab you were talking about. So while you're opening up that other
see if
browser,
I log back in again and try it from scratch, see if it flushes it out.
Yeah, so we'll give Dustin a second there. In the meantime, you can see the screen he was just talking about with the route-based VPN, and where you can put all the information he was discussing there. So let me know maybe when you get it back up, and we can take a look through it. So.
Yeah, let me stop sharing for a second. I'll flush this out of here. And
okay. Yeah, and then like I said, still this is why it's in early preview mode. This is all bugs that we're reporting back into to our business units for their engineering teams to resolve before everybody kind of gets on the platform. We're kind of on the bleeding edge, and sometimes you get cut.
And actually, a lot of the stuff is just because we're coming from number one, we're on an early release of this, and number two, we're coming from VMware corporate, and so it tends to wreak havoc on our cookies that we have, and so that tends to be the cause of a lot of this. That is not necessarily customers don't ever see this, but we certainly do.
Yeah, we put up with the pain so you guys don't have to. That's what customer success is for. That's our job.
All right,
But
so I'm opening up a new private browsing session.
so are you sharing again,
So
or
it's isolated. I will here in a
okay?
second.
All right, just let me know
Get,
when.
I'm gonna get in fully here and get all logged in first. All right, getting ready to share. All right, so you should be able to see I'm on that route-based VPN tab now.
Okay. Yep. We got you going. Yep.
All right, so to backtrack a little bit, if I were going to go through and add a VPN, you will see that the workflow has changed somewhat. So we've got the name here, we've got our remote IP, so that's a remote public IP. If our remote end is behind a NAT device, then we would put its real private IP address here. Let me try to scroll down a little bit so I can get over. We have here, this is where we're going to set up our VTI. So down here, we've got all our encryption settings for phase 1 and phase 2. But here, this is where we would set up our VTI interface. So here I would, I would define some, some /30 here. So let's just use some random space here. Something like that, right? So that would define my address on this end, and then I would go through and I would set up the BGP information. Hopefully I didn't. There we go. So here's where you would go through the workflow of setting up BGP. And so now I'm not going to walk through this entire thing here, but you get the basic idea of the workflow. So configuring VTI, setting up BGP. Now again, once you have that up and running, we automatically start advertising prefixes, and you're off. So that's the big enhancement with route-based VPN. Now going back to the firewalling, let's see. So I was in the process of adding a new rule. So what we'll see here is the firewalling is group based, and so that's another big change from what we've had before. So group based means that I want to define groups of groups of things for my rules, and so in this one, because we're on the management gateway rule set side, we'll see that we have certain system defined groups, and these are very straightforward. So we've got ESXi group, and that is an IP address based group. So they've gone ahead and predefined this group with the address ranges that the ESX hosts are sitting in. So you can lump them all together in one single rule instead of manually creating rules using address space. You can just simply reference a group. Same thing with the NSX manager and vCenter. Now these happen to be /32 address groups, but you get the general concept. And then we of course have user defined rule sets over here. And so I've got a couple of groups that I've put in just to mess with here. And so again, I've created some address-based groups. Now, the grouping isn't restricted to IP addressing. You can also define groups on tags, and so you can go down if you go to your groups here. You see that we have our management groups, which are predefined. We've also had the ability to define some of our own in here, and the reason why they're segmented is because whatever the groups are applied or created here, you can only use them on the management gateways portion of the security of the edge firewall and the distributed firewall rule sets. And so that's why we have two separate sets of groups. And so I can go down and I can create these new groups, and I can either say address based or VM based or whatever it is. And so I can define, I can go through and I can specify individual VMs as part of this group. I can go in and specify different alternative membership criterias. And so you start seeing I can do it based on the VM's name. I can do it on a tag. So I have some additional flexibility here. So this looks a lot more like a lot more similar to what you're used to if you use NSXV on-prem. So you have a lot more flexibility in defining security rules. And so we've ported that over as part of the NSXT release. And so all group based, and you have the ability to define your groups on some flexible criteria. Now, applying these groups, like I said, we're either doing that on the outer tier 0 firewall via this edge firewall rule set, and we have two different areas where we're applying things that apply to the management network and things that apply to the compute network. Or we can go through and use the distributed firewall. Now, the distributed firewall, see if I can get rid of this. The distributed firewall is based entirely on the compute network. So you don't have the ability to define distributed firewall rules for the management network, but you can for the compute network. And so that's what we're seeing here. In this section, they have this concept of you have sections of sections, and so that's what you're seeing over here. So these are the top level container sections, you can almost think of them like. So we've got, they've got some pre-created groups that are the containers of other sections. And once you go into one of these sections here, you can then add a new subsection under that. I'll just name it something a little bit more sensical. Sorry, I already had a section 1, turns out. Once I'm in this section, I can then add new rules. And again, this is going to look very similar to the edge firewall, where it's just specifying source, destination, and service. Now, the difference is that the policy on the distributed firewall is default allow. And so if my rules here are basically going to be either drop or reject if I want to apply them. Right. So that is the main difference between edge firewall. Well, I won't say the main difference, but that is one of the key differences. Edge firewall is default deny. Distributed firewall is default allow. And so again, group based, done in two different workflows, applied two different ways. And so that is the main difference between this and NSXV is on this feature set. Now, on the direct connect side, you can see as well we have a view that is changed somewhat, looks somewhat similar to what we've seen on the NSXV based SDDCs, but behaves slightly differently. And so here we can see that because we're in the process actually of setting up direct connect, it's not actually completely done. So it's partially set up, and so we're receiving a default route from the on-prem side of our direct connect, and then we would normally be advertising out all of the address spaces for the management networks and the compute networks that we've created. However, we're not quite done with this setup, and so we're not advertising anything just yet. And so that's why we're not seeing anything here. But that is the main difference on the network side of things for these SDDCs. And again, I've not gone through everything in its entirety. This is just meant to mainly cover the topics I specifically talked about in the earlier presentation. So on that note, if there are any other questions on any of this stuff, I can talk about it. Otherwise, that is mostly the end of what I wanted to cover here.
Yeah, sure. So if anybody wants to put questions in the chat, or as always, you could always tweet at me at vcloudmatt. So some of the other features here, Dustin, just quickly, is some of the IPFix and port mirroring functionality. Did you want to touch on?
Right. So these are additional enhancements that are in NSXT, and I didn't cover them in the presentation, so I didn't cover them here. But basically, IPFix is essentially flow data. You can get flow data out of NSXT, and then port mirroring is another feature that people have wanted. So basically, the ability to take and effectively sniff the traffic from a given workload on the SDDC and mirror that traffic to another VM. And so that's the high level on those features.
Yeah, and the other thing I guess maybe to touch on briefly, even though it's not the greatest topic, but So service insertion is not quite in yet, right? That's also coming very, very soon.
These are all roadmap items, so I don't know when they're going to drop, but yeah, there are additional enhancements that we'll start seeing. So NSXT is all about net new functionality. So in the current release of the product with NSXV, we had somewhat basic network functionality exposed. So even though NSXV can do a lot of stuff, we're not exposing that. A lot of the reason is we knew we're going to change the underlying implementation, so no point exposing it. Also, didn't want to divert the resources away from the NSXT work, I suppose. And so NSXT represents basically a first release with some of this new, enhanced functionality. It's still not fully exposing everything that's possibly available, but we're going to start doing that, I expect, in little chunks. So we'll have an initial release with this sort of enhancements, and then we'll see future enhancements
And all of this stuff most of the stuff that all the stuff that we showed you from a configuration standpoint is also available via the API. Is that correct?
Yeah, the APIs again. So in NSXV based SDDCs, the API was somewhat restricted as well, per the restrictions of stuff we just chose to not expose with the NSXV based SDDCs. With NSXT, we should have much more of that exposed. Now again, it's all gonna be subject to the permissions model of the SDDC. You're not gonna have the ability to go in and delete transport zones, for example, but you will have much more functionality exposed through the API.
Yeah, I think one of the fancy things that can probably be done, or not probably can be done now, is using tagging features out of products like VRA or our cloud automation engines to tag stuff that can get picked up and have security rules applied to it, which I think
Yeah,
is great.
potentially, and this is not something I haven't looked in great depth at the API here, so I'm not sure where you would actually make calls to apply tags. So you saw tags, for example, on the groups up here. So we could create security tags. I'm not sure actually if that's done through the NSX API or if that's something we're exposing through the VMC API. So that's something we'll have to look at for later on. But yeah, there's always going to be several different APIs for different functions. So the vCenter API does its little bit of the puzzle. NSXT does its bit, and then we have an API on VMC itself. And so
Yeah,
it's
no,
always going to be a question where that's
I think that was a great overview, Dustin. I appreciate that. It's fancy, like I said, like Dustin said, this is definitely in right now what we call preview mode, and all of our releases kind of step through that order. Preview before, I think, what's it called, released, or what's the last
it,
one?
GA is generally
Generally
available.
available. Is that the last step after preview?
I believe I'm not a PM authority, so
Yeah. So,
I'm not
but if
sure.
you are if you are a current customer or a prospective customer, this is something that could be available for you today, depending on your use case and a bunch of stuff. And if not, like we said, it's coming very generally available very very soon here. And with everything VMC, functionality is coming essentially almost daily via different. We have UI updates daily, product updates quarterly, even sometimes in between there. So it's definitely a fast-moving place to be. So just because we say you're watching this video perhaps in a month or two, um, you know, all this stuff might be available that we were saying is not currently in. So always feel free to reach out to me or to Dustin or to our group or to your local salesperson or whoever and see where things currently are, because it is a very, very rapidly developing product. And will always be. I don't foresee a day where we'll ever get any rest really from learning stuff, Dustin, which I guess is kind of the life we chose. But very interesting. So again, thank you, Dustin. Next week we're going to have another member of the team, Z House, and he's going to be on talking about multiple AZ clusters, kind of our concept of stretch clusters. Well, yeah, stretch clusters, I suppose. as a way of putting it. So he's going to be over talking about some of the caveats there, some of the cool features and functionalities. That's been a very hot topic as of late with a lot of our customers. I think this is a great overview because NSXT is, and especially the distributed firewall and a lot of the direct connect private VIF functionality that comes with it, is definitely something that a lot of our customers have been looking into. So I want to thank everybody that tuned in live and anybody that's watching this video for coming by. Like I said, you can look at the events page and you can always sign up for notifications, that kind of thing. Jump in the chat, talk with us. One of these weeks we might just do kind of a podcast kind of week as well, where we just kind of chat with the viewers and answer any of their questions. So like I said, see how it's next week. The week after that is VMworld. Hopefully everybody's going there. If you are, tweet at me. Maybe we can hook up for a coffee or something like that, and chat in person. And if I'll have a session going as well. We have a bunch of customer meetings. A number of our team members also have sessions. I think Paige was on a couple weeks ago, and she mentioned she had a couple sessions as well. So we'll be definitely around and very busy. But we're going to try to do a stream live from the floor. We'll see how well that works out. So no promises. So don't lawyer me again. But yeah, with that, I think we're good for this week, and I hope to see everybody next week. Thanks for tuning in. See you later.